So we'll move ahead and we'll solve another problem. This is a different problem than what we have solved. Okay. Uh, for a for a system shown in the state diagram, find part A of the question. Find the entropy of the source. Find G1, G2, and G3 to verify the G1 greater than G2 greater than G uh, G3, 1, G2, G3. Let me just check the question once again. Yeah. So G1 greater than G2 greater than G3 greater than the H1. Okay, so we need to verify this as well. So the first part we are very familiar with, finding the entropy of the source. All right. So fine. So this is a given state diagram. There is one, state number one, and state number two. There is a probability of 2 by 3, and this is 1 by 3, and we have a state probability of okay, this is 3 by 4, and this is 1 by 4. Now you see we have only two states. All right, so if you remember, we'll first find out the probability of the states. P of 1 will be equal to, in what all ways you can reach 1. From 1, there is a chance that 2 by 3 into P of 1 plus 1 by 4 into P of 2. Okay, so we'll call this is equation 1. First objective is to write down the state equations. All right, so that is for P of 1. Similarly, probability of 2 is 1 by 3 times P of 1 plus 3 by 4 times P of 2. All right, so this is equation number 2. So in the next step, what we do, right, we'll try to get the value of P of 1 from equation number 1. So you can use any of the equations to get the values. So what I try to do, I'll try to relate P of 1 and P of 2. So from equation 1, that is, and I'll try to find out P of 1 minus 2/3 of the P of 1 is equal to 1/4 of P of 2, right? So I will understand that P of 1 into, this is 1 minus 2 by 3 is equal to 1 by 4 times P of 2. So P of 1 into 1 by 3 is equal to 1 by 4 times P of 2. I'll divide that by 1 by 3 because that 1 by 3 comes from the left, right? So this 3 goes to the numerator. So that gives, therefore P of 1 equals to, this is 3 by 4 times P of 2. So we'll call this as equation number 2. So in, no, 2, sorry, 2 is already existing. We have equation 2 with us. So I'll call that as equation number 3. Okay, so put 3 in 2. What happens? Wherever I have P of 1, I'll write 3 by 4 P of 2. So this is P of 2 is equal to uh, can I substitute there? Oh, no, everything becomes P of 2, so it's not possible. Sorry, right? I will not be able to substitute here because everything is in terms of P of 2, which may not give us any required equation. So what I do, I'll use the other one, that is sum of the probabilities equal to 1. Okay, so we know that the P of 1 plus the P of 2 should be equal to 1. Now, if I substitute the 3 in this equation, then no problem, right? Nothing will cancel out, right? I still get the answer. So that is 3 by 4 times the P of 2 plus the P of 2 equal to 1. Okay, so I'll take the P of 2 outside, right? P of 2 is equal to 1 divided by, so 1 plus 3 by 4. 1 plus 3 by 4. So this is 4 plus 3. So 7 by 4. So the 4 goes to the numerator. I think this is 4 by 7. That is P of 2. So when you know P of 2 as this, I can calculate, therefore P of 1 is equal to 1 minus P of 2. So that is equal to 1 minus 4 by 7. Right, so 7 minus 4 is equal to 3. So we got the answer for P of 1, that is equal to 3 by 7. So P of 1 is 3 by 7, P of 2 is equal to 4 by 7. We got it. So we understand that there are two states present, right, in the given system. So for two states, right, I have to find the entropy of each state, right? So that I use the entropy of each of the state to calculate the total entropy of the source, which is the first part of the question. Okay, so we know that. First, let us calculate H1. Okay, right? I'll write a general equation. Hi is equal to summation for j is equal to 1 to n, right? How many states in general you have? This is probability of ith state to jth state into log to the base 2 of 1 divided by pij. So this is the same p which I'm writing. Okay, pij. This is what I am supposed to calculate. Therefore, calculate one by one. So first state H1 is equal to, right? So I have connections between the states like this. So I can write, say, J is equal to 1 to 2. This is P1J log to the base 2 of 1 divided by P1J. So you can see the I value is fixed to 1 here, because I'm calculating the entropy of the first state, right? So that means I'll expand now. So this is P11 log to the base 2 1 divided by P11 plus P12 log to the base 2 1 divided by P12. That's all. From that particular state, whatever connections you have, right, substitute over here. So P11 and P12, let's quickly look at what we are talking about. P11 is this state, starting from 1 going back to 1. P12 is starting from 1 going to the second state. Only these two I'm supposed to write. So 2 by 3 and 1 by 3 are the two terms which I'm going to write here. Okay, right? So using them in the equation, P11 is 2 by 3. So that is 2 by 3 log to the base 2 of 3 by 2 plus P12 is 1 by 3, and this is log to the base 2 of 3 by 1. Please calculate. So when we calculate this, so it comes to be 0.91. It's H, so bits per sim. Okay, then let's do the similar job with respect to the second state, that is H2. So directly we'll write P21 log to the base 2 1 by p21 plus p22 log to the base 2 1 over p22, right? So this means we are trying to substitute the values of the probabilities uh, from state 2. So that means 2 to 2 is this one, 2 to 1 is this connection. So you have 3 by 4 and 1 by 4. Okay, so P21 is 1 by 4, P22 will be 3 by 4. So we'll substitute that here. So this is equal to, right? So 1 by 4 log to the base 2 of 4 plus we have probability 3 by 4 log to the base 2 4 by 3. Please calculate. So this probability, this H2 value is 0.81 bits per symbol. Right. Now, if you remember, the entropy of the source is H. Okay, so you can calculate that as, okay, we'll write the equation now. I is equal to 1 to n, total n number of states we have. The probability of each of the state into H of each of the state, individual entropies, right? I have to substitute. So that means in this case, it should be P1 H1 plus P2 H2. All right. So the probability of the first state, we calculated that as 3 by 7 into H1 just now calculated 0.91 plus the second state has a probability 4 by 7 into H value entropy 0.81. Okay, we'll just substitute and we'll calculate. Just see here, the value of probability P1 and P2 we calculated. You can see here, right? P1, P2, right? Both values we have calculated and we are substituting that. Yes. Okay, so that gives you 0.85. Again, this is bits per message symbols. All right, so first part is done. So the entropy of the total message source has been calculated using this technique. Okay, all right. Now you see, we need to calculate what are the okay, let us assume that we have the symbols given over there, right? So okay, let me assume that what symbol is emitted and when it is emitted also has to be given. So I think I slightly need to modify the question now, which I actually have missed over there. I'll just write that. So if it is 1, starting from 1 and coming back to 1, the emitted symbol is X. Okay, and if at all it is jumping from 1 to 2 or 2 to 1, then the generated symbol is, say, Z. Okay, if you are in 2 and you are coming back to the 2, then the emitted symbol is Y. All right, so X, Y, Z, this particular source basically emits, right, 3 different what you call symbols. Are you okay with that? So this we need to remember. This we need to understand first. Okay, that is, it's actually trying to emit 3 different symbols. That's the first thing. Okay, it emits 3 different symbols. First of all, it emits 3 different symbols. And I also should note that when this emits 3 different symbols, right, there are some probabilities associated with each of the symbols. Okay, so these are the things which I need to remember first. Okay, fine. Okay, so it is given. Assume that this is given. I should have written earlier itself, right? But this will be given. Okay, So what is the order in which, what are the conditions and what will be the probabilities of emitting each of the symbol will be given. Okay, right? So X will be coming whenever you are jumping from state 1 back to state 1. So state 1 to state 2, if it is jumping, then we are trying to produce the Z as a symbol. Okay, and you see, if you are in the state 2 and you come back to the state 2, then we are trying to generate the Y as a symbol. So 2 to 1 jump will generate the symbol that is Z. Okay, fine. Now, right, what are the, let me write. So this is this part I'm trying to answer the second part of my question. Okay, so this is the answer to part 2 of the question, right? Let me first try to write what are the various symbols that we can generate, right? So let the symbols generated, we'll put it into some set. So that is X, or you can generate Y, or you can generate Z. Right? Now you see, I need to calculate what is the probability of X. Right? What is the probability of X I need to calculate. Right? So, uh, can you just guess what should be the probability? I just want to calculate the three things. First, let me write. One is P of X. Then I need to calculate P of Y. Then I also have to calculate the probability of getting a Z. Okay, so this is the probability of a state, right? What is the probability of state 1 into getting an X, right? So you see, let me copy the state diagram written once so that we can use it again now, right? So we require that again. So let me quickly copy this. Okay, so let me write that here. Okay, refer to this and try to answer. Right? I already know something. That what I know, I'll write here. I know that there is a probability associated with this getting a state 1, and I also know that there is a probability of getting the state 2, right? So probability that I get state 1 is, right, we already have written that is 3 by 7. Okay, and probability of getting the state 2 is 4 by 7. We already know this. I have to apply this to calculate the probability that I get X as my uh, symbol, right? You see here, this is the concept I am supposed to apply. In order to get a state X, sorry, in order to get a symbol X, first I need to reach the state 1, right? I should reach state 1. Once you reach state 1, there is a probability of 1 by 3 you get Z, 2 by 3 you get 1, you get X, correct? So now I am looking for the probability of getting X only. So the fundamental idea you are going to apply here is probability of state 1, that is 3 by 7. After reaching the state 1, what is the chance of getting X? That is 2 by 7, 2 by 3, correct? 3 by 7 is the chance of reaching state 1 because there are two states, any one you can get. So after getting the state 1 with the probability 3 by 7, you will get X with the probability 2 by 3. So multiplication rule should be applied. Okay, so this 3 cancels, so the chance is 2 by 7. Probability of getting a symbol X is equal to 2 by 7. Now you see, you apply the same thing to Y now. Probability of getting Y is, first I should get I should reach the second state. So second state is 4 by 7 into, what is the chance once you reach state 2, again you have two things, right? So I should multiply by 3 by 4 now. So 4 cancels, so you have 3 by 7. Now, what is the remaining probability that you get Z, right? If you are in state 1, you have this as the chance of getting a Z. That is 3 by 7 into 1 by 3. Plus, you also have a chance of getting 2, right? Getting into state 2 and then getting into Z. So that will be 3 by 4 into 1 by 4. Is it, am I right? So 3 by 4 into 1 by 4. Is it 3 by 4 into, no. Sorry. My mistake. Right. So first thing is right. 3 by 7 into 1 by 3. And for the second one, I should write the, yes. So it has to be 4 by 7. That is a chance of getting into 2. Then I have a chance of 1 by 4. Correct? So here 4 cancels, here 3 cancels. So 1 by 7 plus 1 by 7, you have 2 by 7. That is the chance of getting the Z. Right? So again, if I try to write, let me try to write in this way, what is the chance of, let me write the probability of the source. Okay, you can call it as S or S to the power 1, whatever we can write, right? So that is equal to, now how many symbols I have? I have 3 symbols. So I is equal to 1 to 3. The probability of getting that symbol, ith symbol, into log to the base 2 of 1 divided by probability of ith message symbol. So now I know I have 3 things. So this is the probability. This itself, this is nothing but yeah, sorry, it's not P of S. Sorry, P of S I'll write separately. This is the equation for the Gn. G1 I'm supposed to write. So this is the general one. Okay, so this is Gn. I'm saying Gn. So here I'll write what is the probability I'm supposed to write. Probability of the source. Now we have 3 sources, right? 3 symbols. First one, it is X, that is 2 by 7. Second one is Y, 3 by 7. And the third one is XYZ, that is also 2 by 7. So this is what is the P of S. Okay, source. Okay, so now I'm writing Gn. This is in general. First thing, whenever I am considering one symbol at a time, now you see only X comes, then Y comes, then Z comes. I'm considering symbols as individual letters. Okay, so when we write that, we call it as a G1. Therefore, G1 is equal to, it's the same thing. P of X1 log of 1 by P of X1 plus P of X2, P of Y log of 1 by P of Y plus P of Z 1 by P of Z. That's all we need to calculate. So 2 by 7 log to the base 2 of 7 by 2. This is for X. Then for Y, it is 3 by 7 log to the base 2 7 by 3 plus 2 by 7 log 7 by 2. Please calculate. That's right. So we get this is equal to 1.55. So this is, again, it's in terms of H only. So we are representing bits per symbol, right? Only G1 is straightforward. For second order, right? For the second set of symbols, right? We have to calculate. Okay, we have to calculate in the following fashion. First, what we do, we'll try to expand the. We'll try to write a tree diagram. Okay, so this is how it works. So let me assume that in order to calculate the G2, right? Now let me write an equation. So G2 is equal to, it's HS square divided by, it's N, right? Gn is equal to, general equation is H of S to the power N divided by N. Okay, N is equal to 2, so I have to divide this by 2. So in previous case also we have that, but I don't have it. I don't have to write the denominator as 1. So that's why we didn't divide by any number. G1 is equal to, right? This is same as, the previous answer is same as H of S to the 1, H of S itself. Okay, so we didn't do any separate calculation there, but here we need to do a calculation. G2 is equal to h of s square divided by 2, right? So first second one. So you can see that in the question they have asked to prove something. So you see second part B question, find G1, G2, G3 and verify G1 is greater than G2 greater than G3 greater than H. So we have to do up to the third part in this case. Okay, so G2 is h of s square, but I know that h of s square means it is a second order extension, right? I have to consider all the possible of combinations I'm going to get, right? When two symbols are two continuous or consecutive symbols are considered. Is it okay? So let's try to do that. So for this kind of systems, right, it's going to be tedious whenever we do the second and the third, right? In this problem we'll do the third also. Okay, so okay, so let us assume that I have two states. So you need to assume initially you might start from the first source, okay, first particular state. So if I write the state as the state number one here, I know that there is a probability associated with that state that is equal to 3 by 7. So this is the probability that I might start with the state one. Now look at the given whatever state diagram, and okay, so this is the given state diagram. I just have to consider this. I have to look at this and I have to answer. Okay, so let me, I'll try to make this small, right? Okay, so I need to look at this and I need to answer, right? I also have the, I'll write the probabilities here. So for one, there is a probability of 3 by 7. For two, there is a probability of 4 by 7. Now, if you are right now present in state one, what are the two consecutive numbers that you might get? Okay, so right now I am in state one, let us assume, and I have two chances. One is that I may get into state one or I may get into the state two, right? So from state one to state one, there is a chance of 2 by 3. And what is the symbol you receive? It is X. Okay, from the state one, I might end up in state two, right, with the probability that is equal to 1 by 3, and in that case I'm going to get the symbol that is Z. Okay, but now my intention is not, so far you can see that you just got one symbol, right? Either you take the upper path, you get only one symbol, you take the lower path, you get one symbol, but our intention is not that. We have to go up until I get two symbols. So what I do, I'll extend. So from one this state, I have a chance of going to the next state, that is also maybe one. Okay, and when I come down, I may have to move to the second state after the first state. Similarly, from the second state I may move to first state back, or second state to the second state. These are the possibilities. Now you see, whenever you consider all the possibilities like this, you get two symbols, right? First symbol is X, then once again I may get X because I'm in state one, I go to state one, get X. From one I go to one once again, so I get this. So this is a probability 2 by 3. 1 to 2, it's 1 by 3, and the symbol received is Z. If you already have Z in place because you are in state 2, you may go back to state 1, again that will give you a Z. Correct? You are in state 2 and you remain in state 2, right? There is a different probability. So let me write that. This is 1 by 4 and this is 3 by 4. Correct? You get a Y. Again, you see, this calculation is only for assuming that you started with the first particular, what you call, you started with the 1. Okay, but there is a equivalent chance that, right, you might have started. Okay, let me write here. What are the chances? So here you see I get X as my symbol. So what you get here, this is XZ, right? Here I get ZZ, correct? So the last one gets ZY. isn't it? So let me write a probability also. So probability of xx, let me write here. There is another probability of xz I can calculate. Probability of zz I can calculate. Okay. And I can also calculate probability of zy. So how do you calculate? This is the rule. So multiply all the probabilities you get along the path. For example, xx is 3 by 7 into 2 by 3 into 2 by 3. Okay, so that's what will be this. Is it okay? So anyway, let me write that. You keep calculating them. All right, so I have 3 by 7 into 2 by 3 into 2 by 3. So there is a chance of repeating these values. So let's hold on. This may not be the final answer. Okay, so we have to consider the other version as well. So that means I might start with the state 2. So what is the chance of beginning with the state 2? That is 4 by 7. Okay, right. So right now I am in state 2. I might move to state 1, or I might move to state 2 as well. 2 to 2, right? So when you are in state 2 and you move to state 2, you get y as your symbol. Okay, and what is the probability 2 to moving to 2? It is 3 by 4. You are in 2, you get a chance to move to state 1 with 1 by 4. So when you move like that, what is the symbol you obtain is z. Is it okay? Okay. Now, I am in which particular stage? I'm in the state 1 now. So I might move to state 1 or state 2. So from 1 to 1, there is a certain amount of probability that is equal to 2 by 3, right? So you are in state 1 and you can move to the state 2 with the probability that is equal to 1 by 3, right? Same thing. You are already in 2. You can go to state 1 or you can move to state 2, correct? So 2 to 1 is 1 by 4. 2 to 2, the probability is 3 by 4. So let me write the samples I might get. 1 to 1 is x, 1 to 2 is z. All right. Similarly, 2 to 1 is z, and 2 to 2 is what? 2 to 2 is y, correct? All right, so let us try to write the symbols I get in this case. So first one will be the zx, okay? Then I have, so you see zz is repeated now. Previously I had a zz, now also I have another zz. Okay, then I have yz and I also have yy. So calculate. So probability of zx, you see zx, I don't think we have a zx earlier, right? This is a new symbol, so I can directly calculate, right? So P of zx is equal to how much? You have 4 by 7 into 1 by 4 into 2 by 3. So P of zz is equal to 4 by 7 into 1 by 4 into 1 by 3. Then P of yz is equal to 4 by 7 into 3 by 4 into 1 by 4. And I have the probability of obtaining yy is equal to 4 4 by 7 into 3 by 4 into 3 by 4. Hello, can you hear? Okay, so what we are supposed to do here is that we need to look at these calculated probabilities carefully, and if any of the value is repeated, then I should add them to get a new value. For example, right, the ZZ here and here. So because of the ZZ being repeated, right, ZZ can occur either starting from state 1 or from state 2, right? I will make a new value of ZZ now. Okay, so the probability of ZZ, let's try to calculate. Okay, so that's the new value which you are substituting. Other values are fine, right? You see, none of the other values repeat, correct? There is a xz which is different from the zx, so no problem with that. Okay, right. So similarly, we have xy, not xy, sorry, yz and zy. They are there, but they are different. You don't have to worry, right? So therefore, I just have to update only one value, that is for ZZ. So what is that value? Look at the first one. It gives you 3 by 84. Similarly, from the second one, I get the P of ZZ, that is equal to 4 by 84. Correct? So just add them together. So that is 7 by 84. Right? Anyway, we can simplify that. It's I think 1 by 12. 7 ones are 7 12s. Okay, 1 by 12 is the answer, right? Anyways, you can see that P of ZZ here as well as here. Same thing. Okay. So only for ZZ, it is repeated in both the cases. All others are not repeated. Yeah, different. You need to add, right? ZZ comes in both the cases. The ZZ can occur. You can obtain, yeah, symbol ZZ can come from this way as well as this way. Okay. Because of that, I have to get the new value of the new value of probability of obtaining ZZ. Okay, so that's what I'm calculating. P of ZZ, I'll try to update, right? So individually, we had calculated two values, add them together to get the new value, which is the actual value. Only ZZ will be this value, other values will remain same. Okay, so now what are the possibilities you can check here? There are 7 possibilities: XX, XY, XZ, right? Then YX, you have YX? No, you don't have a YX. Okay, let me write this so that I can avoid the confusion. Okay, what are the symbols, right, present in the S square? So S square can have the following symbols. So starting from, let me try to write the symbols first so that you can write down the probabilities later. I may get XX, XZ. I may have ZZ. Then I have the ZY. ZY is possible. Okay, ZX is possible. It's a different one. Then I can have YZ and YY. So these are the total possible symbols we have in the list. Now I'll write what are their probabilities. Probability of s square is, just write the corresponding probabilities over here, right? I can see that xx happens with the probability that is equal to, what is that? It's a 12 by 63. Okay, I think 12 by 63 can be reduced to it's a 3 fours are and 321s are, right? So I'll just write the simplified one. Just verify. The next one we have xz. Xz, I can write it as 6 by 63, so 2 by 21, right? Then zz, just now we have calculated, that is 7 divided by, it's 7 itself cancels, so 1 divided by 12, okay? Then we have, okay, zx, 8 by 84, zx is zx or xz? Okay, then I have zy. What's the value of zy? 9 by 84. So 9 by 84 means I can once again cancel. So 3, 3 are 320. Okay, then I have for the zx, yz, then I have the yy, 4 nines and 420. Okay, these are the probabilities. Okay, so P of s squared. Now what I want, first I want to calculate h of s squared, right? How do you calculate h of s squared? It's for all the symbols. Just calculate how many symbols you have. I is equal to 1, 2, 1, 2, 3, 4, 5, 6, 7 symbols. For all the symbols, simply multiply by P of I log to the base 2 of 1 by probability. That's all. Right, so simply calculate this. So we have 4 by 21 log to the base 2, 21 by 4, plus there are two terms of 2 by 21 log to the base 2. Okay, so the probabilities will substitute like this. So that is 4 by 21 log to the base 2, 21 by 4. Then the 2 by 21, we can see that there are two terms, right? So plus 2 into 2 by 21 log to the base 2 of 21 by 2. Then 1 by 12, it's only one term. So 1 by 12 log to the base 2, 12. Then we can see that 3 by 28 is repeated twice. So 2 into 3 by 28 log to the base 2, 28 by 3. Then 2 by 21 is done. 3 by 28 is also over. Plus 9 by 28 log to the base 2, 28 by 9. Please calculate. We get this is equal to 2.61, right? Okay, 2.61. It is h, right? So it is once again measured in the same format. So bits per symbol. But I don't want h of s square. I actually need the g2, right? G2 is the average bits present in the message, right? Second, whenever we consider the message consisting of two symbols at a given point of time, so that means I have to calculate the h of s square by 2. So 2.61 divided by 2 is what we require. 1 point maybe 305 or something. Okay, bits per symbol. So we got a G2 now, right? So what we expect now, we want to go to the next level, right? I have to create the symbols, right? uh, in such a way that each symbol consists of three subdivisions, or three at least 3 units, or exactly 3 units, or three different three possible symbols will be clubbed together to get a message. All right, so for which I'll try to save some time, I'll just copy this and then I'll try to expand. I'll use the same diagram, okay, so that I can reuse it. Now we see we need to create the, so what first, let me write the equation required. So I need to calculate G3, that is nothing but H of S cube divided by 3, right? Okay, so anyway, let me start with that diagram which we had written. All right, so this is what, okay, so let me expand from here, right? Each symbol can give you one or two once again, right? So that will be the third extension. So you can see here, I may go to 1 and maybe we'll go to 2, right? From 2 also you may go to 1, 2 to 2. So 1 onwards I may go to 1 and 2, right? From 2 take it to 1 or 2. So this is what generates the third symbol. So 1 to 1 will be x. So 1 to 1 is 2 by 3, and 1 to 2 is 1 by 3. So you are in 2, you are going to 1 with the probability 1 by 4. You are in 2, you may go to 2 with the probability 3 by 4. So you are in 1, you may go to 1 with the probability 2 by 3 and 1 by 3. Then you are in 2, 2 to 1 will be 1 by 4 and 3 by 4. So like write the symbols that you are going to generate. So X, this is generating Z to you, you are in Z. So when Z, you may get a 2 to 1 will be a Z, 2 to 2 is Y. Okay, 1 to 1 is X, 1 to 2 is Z, 2 to 1 is a Z, and 2 to 2 is a Y. So already we know that what we get. So I'll write the symbols I get here. So this is X, X followed by X. So this will be X, X, Z, X, Z, Z, X, my mistake, sorry. It should be X, Z, and Y, right? Okay, X, Z, and Y. Then we have Z, Z, X, Z, 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 Y, Z. Then I have Z, Y, Y. All right, so these are the various calculations we can perform, right? We know the probabilities, and now you need to calculate the individual probabilities. Okay, probability of each of the terms we know how to calculate, right? So for the first one, it is 3 by 7, 2 by 3 into 2 by 3 into 2 by 3, right? Okay, fill this, take your time, and then we'll continue. So what's the first value? 8 divided by, okay, 8 by 63, 4 by 63, 1 over 42, 14 by 42, okay, okay, 9 by 112. So this is one set. Starting from state 1, I end up like this, okay, but I have another option that I might start from this state as well, correct? So for that reason, I am supposed to consider the second diagram. So we'll start from there and then we'll try to expand this further. Okay, so this second diagram, okay, I'll just paste it. Okay, so from here, let us try to expand this further. So from the first one, I can go to 1 or 2. So from the second one also, go to 1 or 2. 1 or 2, 1 or 2. Okay, write the corresponding probabilities, right? So 1 to 1, you have a probability 2 by 3. 1 to 2, it is 1 by 3. 2 to 1 is 1 by 4. And 2 to 2 is 3 by 4. Okay, so this is 2 by 3, 1 by 3, 1 by 4, 3 by 4. Let's also write the symbols, right? 1 to 1 will be X, 1 to 2 is a Z. So 2 to 1 is Z, 2 to 2 is a Y, 1 to 1 is X, 1 to 2 is Z, 2 to 1 is Z, 2 to 2 will be a Y. So corresponding to that, we'll write the symbols drawn now. So here I'm going to get ZX, X, ZX, Z, 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 ZZY, YZX, YZZ, YYZ, and YYY. Calculate the individual probabilities. Later on, we'll check if something is repeated, we'll update. Okay. So the first one is a 4 by 63, 2 by 63. Okay. 1 by 28, 1 by 28, 1 by 14, okay, 27 by 112. Okay, so now what we do, we'll write down all the probability. Symbols are not required, only the probabilities are required. Okay, so I'll quickly write P of SQ. All the terms which we have, we'll write it here. So it starts from 8 by 63, 4 by 63, 1 over 42, 1 by 14, 3 by 1112, 9 by 1112, 4 by 63, 2 by 63, 1 by 28, 1 by 14, 1 by 28, 9 by 1112, 27 by 1112. So these are the overall symbols that we have. Okay, so now what we have to calculate, we have to calculate the H of SQ. So for every term, I just have to calculate the probability and log of that. So we'll do that now. So this is the 8 by 63 log to the base 2, 63 by 8 plus, I think 4 by 63, we have two terms. So 2 times 4 by 63 log to the base 2, 63 by 4. Then 1 by 42, 1, 2, 3 we have. Okay, so plus 3 times 1 by 42 log to the base 2 of 42 by 1 plus 1 by 14 log to the base 2 of 14. Then we have one term, that is 3 by 112 log to the base 2 of 112 by 3 plus 9 by 2 terms. Okay, 2 times 9 by 112 log to the base 2 112 divided by 9. Then we have 2 by 63 plus 2 by 63 log to the base 2 63 by 2 plus 1 by 28. There are two terms, 2 times 1 by 28 log to the base 2 of 28. Then okay, I think we have 1 by 14, one more term. Okay, so I'll just do this as 2 by 14. Okay, so the term which we had earlier also I wrote 1 by 14. I'll make it 2 by 14. Okay, so plus the 9 by 12 is over. 27 divided by 112. Okay, this is log to the base 2 112 by 27. Okay, so you can see that when we solve this, whatever answer I got, I'll write here. This is 3.53 bits per symbol. Okay, so this is actually h of s cube. So using h of s cube, I can write g3. G3 is equal to this h of s cube divided by 3. So 3.53 divided by 3, approximately 1.17. All right, this is also bits per symbol. Now comparing all of them we got so far, right? It can be proved that the G1 is the largest one, then we have G2, then we have G3 and the H1, right? By comparing all the values, we can say that yes, this is valid. Okay, so that is the required answer.